faithfully delivering value, interpreting great books from around the world. Hello, this is Sally's Book Talk. I'm Lynn Bohu. Today we're diving into The Machine Prophet, subtitled The Minimalist Economics of Artificial Intelligence. Just from the title, you know this tackles today's hottest topic. It's about AI, but totally different from other AI books out there. Instead of marveling at the tech's power, it takes a fresh angle. From an economic viewpoint, it shows how AI will transform our daily lives. A key point, though written by three top Canadian economists, and though economics is right there in the title, this isn't about abstract theories, but AI's real essence. It teaches how to view this tech and actually make money with it. Before specifics, the book establishes a core economic lens for understanding tech impact, which boils down to two words: cost, like how we credit Edison's light bulb for modern nights. But economists say its real impact came from not technological brilliance, but radically reduced lighting costs. How so? Free electricity lighting methods existed. Matches, candles, oil lamps all worked. But only the wealthy could afford them regularly. Simply put, they were too expensive. Stats show early 19th century lighting cost 400 times today's prices. For most, night lighting was a luxury, better to sleep than burn money. Only when bulbs made light affordable did nighttime illumination become universal. So what truly lit up human nights wasn't the light itself, but light that was cheap enough. You see, this is where economists' rationality shines for new tech like AI we're discussing. They don't care if it's cool or achievable. They focus on whether it's cost effective. Therefore, throughout this book, the authors analyze how to apply AI in various scenarios to maximize cost efficiency. Here, let's clarify what economists view as artificial intelligence. Because for this question, scientists would tell you that AI's core is a bunch of complex, magical algorithms. But in the author's view, AI's core boils down to one word: prediction. Its mechanism is simply using algorithms to analyze past data and forecast the future. In fact, forget AI, even humans make judgments based on past experiences to predict what's ahead. For example, seeing dark clouds overhead, we decide to bring an umbrella when heading out. Look, this decision process involves combining past data, knowing that cloudy skies often lead to rain, so you predict it'll likely rain today and opt to bring an umbrella. However, in the past, only humans could handle such predictions, or they were far more accurate than machines. But now, with better algorithms and more data, machines predict faster and more accurately, even outperforming humans in efficiency, precision, and cost. Thus, ultimately, as the book's title says, AI's essence is a prediction machine. So how exactly does AI apply predictions to add value in our daily lives? First, let's outline AI's three application scenarios. One is pure prediction. The second is decision-making in complex situations. The third is executing specific tasks. How about that? Does that sound a bit abstract? No worries, let's explain each one with examples. For instance, online shopping. In China, it's Taobao. This book, Amazon, is discussed, and its operations cover all three AI application scenarios. For example, in Amazon's operations, they predict what products customers will order based on past sales data. Introducing AI here is our first scenario, pure prediction, where the core goal is accuracy. The second scenario for AI is decision-making. Amazon decides which products to promote or discontinue based on customer behavior predictions, like stocking more foundation or eyeshadow. That's when AI helps us make decisions. The final third scenario is execution, fulfilling and shipping orders based on purchases. Here, AI's goal is predicting how to minimize packaging and shipping costs, that allocating goods across warehouses or planning optimal delivery routes. This is AI's third application scenario, task execution. Let's briefly recap. AI primarily functions in three areas here. First, prediction. Another is market predictions, meaning decision-making in complex situations. And finally, practical execution. So how do we use AI across these scenarios to maximize benefits? Or why does this book emphasize these three scenarios when discussing AI? This relates to their different demands on AI. For pure prediction, like tomorrow's weather or market preference for red versus green clothes, what do people expect most from AI? Just two words: accuracy, easy to grasp, because it's about predicting objective future facts. We use AI instead of human guesswork precisely because it's more accurate. But for decisions like AMAP or Baidu Maps, suggesting route A or B, accuracy isn't the sole measure. Since every route is clearly defined and accurate, the standard for judging AI shifts to another word: optimal, helping choose the best solution among possibilities. See, our expectations for AI change in this scenario. At the execution level, like inventory management, packing, or shipping, AI's purpose becomes crystal clear: saving money. So across prediction, decision making, and execution, our demands on AI differ. Now, how can we best leverage AI? We need case by case discussion. First scenario: pure prediction. Our top priority: accuracy. So, how accurate is AI's prediction really? How do we use it for the most precise results? First, AI's accuracy is often highly reliable and improving at astonishing speed. Take banks' most common prediction need: loan fraud detection. After someone borrows, banks predict repayment likelihood to take early action. In the late 90s, machines predicted loan fraud with 80% accuracy. Decent but not great, yet by 2000 it hit 90 to 95%. Today, an astonishing 99.9% accuracy rate. Now, banks delegate this to AI, slashing labor costs. But cost saving is just one factor. The real reason to use AI for prediction: its precision. The book notes a key pattern. With big data, machine predictions far surpass human accuracy. Humans overlook critical details in massive data, while machines spot hidden patterns and connections. For example, a credit card user usually only buys very cheap daily necessities. But suddenly, one day, they apply for an overdraft to buy a pair of expensive sneakers. Then bank staff would suspect, hey, is this transaction credit card fraud? But AI can detect from historical records that this person buys sneakers annually around this time, so it wouldn't mistakenly reject this transaction. Thus, this is AI's advantage in handling massive data. Moreover, AI can avoid irrelevant factors. For example, human cognition is often influenced by non-factual factors. What does that mean? The most common situation is that the facts remain the same, but different descriptions lead to biased perceptions. A study found that when surgeons are told the 30-day survival rate is 90%, 84% would choose surgery. But if phrased as a 10% mortality rate, the proportion choosing surgery drops to 50%. Think about it. These are doctors, professionals who understand surgery well. Their perception of the same surgical risk varies so much based on phrasing. So you can imagine, for the human brain, interference like emotions and biases are hard to avoid. But this isn't a problem for AI, whether you say 90% survival or 10% mortality. To machines, these phrasings are identical. Their understanding isn't biased by emotions. Since they lack emotions, machines are more accurate in predictions. But can we conclude that AI has completely replaced humans in prediction? The book's authors say, not yet, because machines' focused ability to find correlations in data can sometimes lead to mistakes, even absurd ones humans wouldn't make. For instance, a hotel during peak season used to set high prices, but still booked many rooms. While in low season, prices were lower, but room bookings remained scarce. When AI learns from past data, it builds connections between prices and room bookings. But the problem is, machines might misunderstand the causality between price and occupancy. Thus, they could reverse or misplace cause and effect relationships. For example, it might not realize that peak seasons, high prices and bookings occur because market demand is huge. Hotels raise prices precisely because more people are booking. Instead, seeing price booking correlation, the machine might make an absurd prediction. Thinking raising prices increases bookings, clearly illogical. What does this machine prediction failure reveal? AI focuses only on data but lacks basic human cognition. It misses common sense, unable to distinguish reasonable correlations leading to prediction failures. Another AI prediction limitation, data dependency. As mentioned, AI accuracy requires massive data volumes. With insufficient historical cases, AI's accuracy can't be guaranteed. Take US presidential elections. Only every 4 years, just 58 elections over 200 plus years. Each has unique candidates and shifting political landscapes. Expecting accurate machine predictions here is unrealistic. Like the 2016 election, even near voting day, predictions were wildly off. The New York Times' AI gave Hillary Clinton a 95% win probability on election day. And we all saw the result. It became a laughingstock of machine prediction. So the book's first conclusion, balance AI's cost savings against its error-induced losses. Overall, the most cost-effective prediction method isn't pure human or pure AI, but a hybrid. AI makes initial predictions, then humans verify reasonableness. Alternatively, humans predict first. Then AI screens for human errors, saving labor while avoiding AI risks. This human-machine collaborative prediction approach already exists and works effectively. For metastatic breast cancer diagnosis, AI achieves 92.5% accuracy, while doctors reach 96.6%. Combining both boosts accuracy to 99.5%, reducing errors from 3.4% to 0.5%, an 85% improvement. So for pure prediction, this book recommends human AI collaboration to maximize accuracy. Now, having covered prediction, let's explore AI's role in decision-making. Breaking down decision-making reveals its close connection to prediction. Decisions consist of prediction and evaluation. Specifically, predict outcomes for each option, then evaluate to select the benefit-maximizing solution. As mentioned, AI excels at prediction, but that's only half the decision process. The crucial remaining step is evaluating the optimal solution. Is AI suitable for this? The core challenge is defining what optimal actually means. What exactly constitutes best solution? Take this book's example. A job site used AI to optimize user pricing. Simply put, algorithms analyzed historical payment data and user patterns, predicting the revenue maximizing price. Frankly, calculating this isn't hard, but after raising prices to this ideal level, the results weren't as expected. They found that after 4 months of the machine calculated pricing, short-term gains came at long-term costs. Users fled to cheaper competitors. So this machine optimized solution wasn't optimal at all. It caused losses. We must realize between short-term gains and long-term benefits, which truly serves our interests, which is optimal. This evaluation work, machines simply can't do. It still requires humans, and this is likely irreplaceable by machines for the foreseeable future. Machines can't grasp human preferences. They calculate outcomes, but can't weigh intangible values. Outcomes aren't purely good or bad. They mix benefits, drawbacks, and probabilistic risks. So among complex options, which meets the optimal standard? Machines don't know. Even humans often decide based on gut feelings that shift with context. Though machine decision-making faces this optimality definition problem, we shouldn't ban machines from decisions entirely, because sometimes optimal choices have clear priorities. Like a rescue robot in a fire, save humans first or pets. Defining optimal is critical here. In emergencies, saving time outweighs perfect human evaluation. Take a Mars rover predicting a cliff fall or sandstorm. Should it proceed or halt? If it sends predictions to Earth for human evaluation, the delay could be catastrophic. So at this point, we need to teach artificial intelligence to make evaluations and decisions. Or in such situations, making any decision is better than doing nothing and just waiting. Moreover, although AI can't sense human decision-making tendencies, it can predict them by learning from vast amounts of data. For example, When self-driving cars encounter emergencies, it's not about programming the car to memorize responses for every possible incident. Because there are too many scenarios, you can never cover them all. But instead, they teach the machine to think like human logic. That is, if a human were driving in this situation, what reaction would they tend to have? Following this approach, the machine simulates human responses to handle emergencies, reducing risks like in self-driving cars. And so, to summarize on decision making, when the optimal solution is clear, machines can handle it fine. But when it's unclear, humans should be the final deciders. Of course, in certain cases, we'd rather tolerate a solution not being optimal than incur losses from high costs. Therefore, letting machines handle the entire decision process is most cost effective. Now, after discussing decision making, let's explore how AI applies to executing specific tasks. As mentioned earlier, for task execution, the key goal is cost saving with two approaches: improving work efficiency or replacing human labor with machines. First, let's examine the efficiency issue. Interestingly, in many workflows, it's not the individual steps that slow things down, but the handoffs, transfers, and waiting between them that consume the most time. A famous US life insurance company called Mutual Benefit Life found that each insurance application requires 19 people across 5 departments going through 30 steps. If each step proceeded without interruption, it would only take 1 day to complete. But in reality, each policy takes 5 to 25 days, with time wasted on handoffs between steps. So, if machines can automate workflow progression, efficiency skyrockets. Beyond efficiency, optimizing process advancement, AI also enables machines to handle labor-intensive tasks like Amazon's order fulfillment and packaging. Relying solely on humans requires maintaining suitable warehouse conditions, temperature, lighting, plus massive energy consumption, simultaneously incurring huge labor costs. Letting machines handle it saves far more than pocket change. Here's a detail I puzzled over before reading this book. Is teaching machines to fulfill and pack orders really that hard? After all, we automate cars and planes with thousands of components. What's so tough about shipping packages? The authors reveal packaging is actually harder than assembling aircraft because plane or car parts are highly standardized. Set the program once and it's done. But packaging varies wildly. Items differ in size, shelf position, fragility. Too much force breaks them, too little won't dislodge them. To solve this, Canadian AI startup Kindred created specialized sorting robots, using AI to train robots to mimic human sorting work. But currently, machines only learned to identify items and approach them. Actual grasping still requires humans remotely controlling robotic arms. Still, this is a major breakthrough. No more humans racing through warehouses. Thus, energy needed to maintain warehouse conditions plummets. This shows AI, human collaboration in action, and reminds us that AI implementation, even in concrete tasks, isn't easy. That's the essence of the machine profit covered. Of course, at the end, the economists highlight key points to note. For instance, AI's impact largely depends on algorithms. So they remind us, don't assume all AI is advanced. Different algorithms yield vastly different results. Don't blindly worship the AI concept. See through to the algorithmic essence. Societal issues also matter. AI might worsen inequality. Since AI handles repetitive jobs, low-skilled workers competing with it face wage cuts. So who benefits most from AI? The well-educated, high-skilled elite. They control advanced tools, learn faster, build barriers, and capture more value. But we can stay optimistic, view AI replacing labor as liberation. Plus, some jobs aren't as simple as they seem. Take long-haul truckers, often called most AI replaceable. They might keep jobs. Imagine self-driving truck convoys rolling through desolate areas. Suddenly, a figure darts out. The AI truck halts immediately, but a waiting gang swarms it, turning the truck into a sitting duck. The cargo becomes easy pickings for robbers. So beyond driving, cargo security is a trucker's vital duty. Just having a human aboard deters thieves. Thus, AI only driving isn't sufficient. Future truckers may still ride with goods, but skip exhausting driving. Though driving jobs vanish, standard wages for new roles emerge. Every cloud has a silver lining. In short, AI will reshape our lives and work. Entrepreneurs, experts, or workers, none escape this technological wave. So, when we close this book, maybe we should take a page from economists and do our own cost benefit analysis. To not just survive, but thrive in the AI age, we got to double down on areas AI can't handle, like human communication, perception, common sense, and judgment, to really shine a light on our strengths. Bottom line, in this era of change, sticking to learning new stuff is always the best defense against getting left behind. And sadly, in this new tech world, the folks who'll get hit hardest are those not ready for lifelong learning. That wraps up our dive into the machine prophet. Book notes are below the audio. I'm Lin Bohu, Sally's Book Talk. See you tomorrow.